By the instructions, we got the pieces we needed and built the robot. It was very complicated, but working together we got it done.
Recording.
Next, we had to program our robot. This was a lot harder than it looked, because robots interpret their instructions literally, so we had to spell out exactly what we wanted it to do. For example, instead of just telling the robot to go, we had to tell both motors to run, make it wait until the motors went for a certain amount of rotations or degrees. Then we had to tell it to stop. Using a computer program, we learned how to make it go forward, backwards, left, and right.
So far this year, we have learned to come to a happy medium when we do not agree, which unfortunately happens a lot. We have also learned to communicate better with other people by explaining what we are doing and why. This helps us to do our work faster and better.
Record.
Next, we had to do the math. Mathematics also play a large part in programming our robot. Of course, you can just plug in a random number and skip the details, but if you want a certain distance or turn that you need the robot to go, you need to work it out. To find the degrees needed to go a certain distance, you first need to know the circumference of the wheel you're using. The circumference is the distance around the rim of the wheel. You can take the distance you want to travel divided by the circumference of the wheel to get the number of rotations the wheel needs to go. From there, you can just take the rotations times 360 to get the degrees needed to go a certain distance. Next was to measure the turns. This was a little bit harder because the distance the wheel has to travel wasn't in a straight line, so we couldn't just measure it with a ruler. First, we had to take the degrees we had to turn over 360 times the distance the wheel has to travel over the circumference of the circle traced by the wheel. Our variable was the distance the wheel had to travel. Once we had everything else, we could cross-multiply and divide to get our variable. So first, we needed the circumference. Circumference equals diameter times pi. The diameter was a little bit complicated, but easy. Since a robot pivots on one wheel to turn, the radius of the circle traveled would be the distance between the two wheels. So then we could take the radius times 2 to get the diameter, times pi to get the circumference. After cross-multiplying, we had the distance we needed the wheel to travel, and we could treat that just like before. Distance divided by wheel circumference times pi.
Go.
The sound sensor picks up different sound waves and decides whether it is loud or soft. We use the sound sensors to start up the robot using sound instead of pushing the button. To do this, we use two different pieces of our program. One waited until it sensed a loud noise, and the next waited until it got quiet again. We could put this on both sides of our program so that we could make it go when we clapped or stop when we clapped.
The light sensor, located at the back of our robot, was used to follow a line. It shone a light onto the ground, and from the reflection could distinguish between a light surface or a dark surface. We used this in a loop to track a line and follow it. With our program, if the sensor saw dark, it was the tape. So we told it to go forward, or in this case backwards, so that it went like this, and a little bit to the left, off the tape. Then, once it saw light, we told it to go forward and a little bit right, back to the line. With the loop, this occurred over and over again, so that it basically zigzagged along the line. We put the sensor on the back so that it would not move so much when our robot turned. This way, it could go faster and still track the line effectively.